This is the first chapter of a nice project about the genesis of microcrystalline silica, and is made in a conference series of small video. So in this first video we will talk about the genesis of jasper, and in special kind of jasper called Oceanic Jasper. In a recent classification of jasper based on its precursor, Oceanic Jasper is one of 4 class. 3 of them are the result of alteration of hard material, and the 4th one, the chemical jasper, is a jasper made from direct precipitation from a solution. So the 3 group of jasper made from hard material are actually some kind of pseudomorphs. So oceanic jasper are pseudomorphs of jasper after opal, organic opal. Volcanic jasper are the alteration of volcanic glass, and jaspers on some kind of fossil are the result of the substitution of organic matter. So if we talk about the oceanic jasper, we can split in 2 groups. The group of flints and the group of abyssal jasper, that are the normal red jasper that everybody knows. So for understanding these 2 groups, we have to understand before the concept of carbonate compensation depth, that is a depth in the ocean between 4 and 5,000 meters, depending on temperature and on salinity, and this depth is the depth where every carbonate that arrive from above is totally dissolved. So above this line, a piece of carbonate like a calcite or aragonite shell can fall down on the floor and make a deposit, the carbonate deposit. So this is the place where carbonatic shells are formed. Under this line, no carbonate are allowed. So all the carbonate are dissolved, and the silica is the only deposit that remain. So the piece of opal shell that fall from plankton that die, that fall on the seafloor, are deposited only under the carbonate compensation depth. So above the carbonate compensation depth, this silica is dispersed inside the very thick carbonate deposit, the limestone deposit. There are 2 groups of life of organisms that produce siliceous shell, the diatoms and the radiolarians. The diatoms are usually flat with round and triangular shape, and radiolarians are more globular and with many spiny and a lot of hole. Both of them are important because they live in the plankton, and they are widespread in all the ocean. For this reason, we can have in every ocean and in every kind place of the planet, we can have the same deposition. There is other animal that have siliceous skeleton, like spongy, but because spongy are bentonic, they are not important for the formation of jasper. So this is the geological environment of the oceanic jasper. So we see the CCD, the continental shelf made of carbonate, a long sequence of carbonate, where bed of flint nodules are concentrated. Some flint can also be resedimented under the CCD in the fan delta, submarine fan delta, that are the result of the deposition of the submarine canyon that bring material from the shelf, and because the deposition is so fast by turbidite, so avalanche, so the deposition is fast, and there is no time to dissolve the carbonate. So there is more rare, there is the possibility to have some flint under the CCD, but most of the flint are in the continental shelf inside the carbonate sequence. And the abyssal jasper are a big sequence of stratified jasper that are on top of the oceanic crust without any carbonate mixed. So this is the situation. We have, this is the sequence of the oceanic crust. So this is an ophiolitic sequence. Ophiolite is a kind of piece of oceanic crust that is involved in the formation of a chain, of a mountain chain. So this is called usually green rock or black rock, because is basalt or volcanic rock. In this case is intrusive subvolcanic rock like gabbro, and the top is basaltic sheet and pillow. So all this sequence can be altered in serpentine, and for this reason are green rock. So all these rock are piece of oceanic crust involved in the orogenesis, in the formation of a mountain chain, and almost always they have at the top seam-bedded jasper sequence. So this is an example from Italy, is banded jasper from Val Graveglia. We see the red jasper that are in this case alternated to quartz, and they are strongly folded because of their implication in orogenesis. So this is an example, not folded, of abyssal jasper from Venezuela. Is a very nice place, is in a national park, and this a 6 sequence of red jasper, and the river flow along this formation that is very tough and difficult to erode. So it's very nice. And another example very similar is in Italy, and is the Popogna Quarry near Livorno. That is a small river that is flowing inside this red jasper sequence. So what the aspect of this jasper, this is the normal jasper we know, everyone, and this the typical red jasper used for aquarium. Often is stratified, but usually internal they lack internal structure, so it's just red with some band sometimes. But the material is very tough and was used since a very old time for the production of beads and seal. The production of seal was very important because it's one of the more tough material in nature, and the seal was the signature of a people for make the signature in the lacral, and it must to be something that survive for all the life of a people without broken. So this is another example of a small abyssal jasper. The Avatar jasper from Arizona is a small sequence of banded red jasper, and is associated with a lot of iron that is responsible for the red coloration. This is another typical abyssal jasper, the snakeskin jasper from Australia. Is thinly laminated. In Italy there is another similar example, thinly laminated from Sardinia Island, but is not very used for the production of object, because in Italy there is not tradition of this kind of lapidary works. This is the situation of flint. Situation is quite different. Flint are never, rarely colored. They are concentrated in bed, but most of this bed are removed to form nodules with a process that is called boudinage, from the French word that means sausage. So this process from a continuous bed, the pressure of the underlying deposit, when the jasper bed is always plastic, so this pressure remobilize the bed to form nodules. So the result is that all the flint are dispersed in the carbonatic sequence in the shape of nodules. But all these nodules are the result of some individual beds. Each bed represents a massive die. So diatome or radiolarians usually they have a blossom when the weather conditions are optimal, and in this blossom they can cover a part of the ocean for a very short period, and when they die they fall down altogether and they make a sheet. So this sheet represents one massive die of plankton. So this is the genesis of the nodule. And the internal structure of flint are very poor, and just few rings, and they are also very poor in colors. The most important for lapidary purpose is this flint from Poland, but you see that if the pattern is nice, the color is always gray. This example from Russia showed two nodules yet stick together, and this is a clear example of boudinage. This small white dot is some remain of the fossil included inside. The Anglophone people distinguish between two materials very similar, that is chert and flint, that are practically analogous, but chert are usually in thicker bed and are more colored, and in this case it's possible to distinguish inside the remnants of microfossils, because in this case, because the bed was more thick and more continuous, the boudinage process is less effective. And the other word is flint, that refer mainly to nodular material. This is very common, and it was used since Paleolithic for the production of arrow. And this is the result of thin bed of dyed organism that are removed by boudinage. This is a typical chert material. This is one of the more colorful in the world, and this mukaite from Australia, and this a kind of radiolarite, where it's possible to distinguish inside more than 20 different kinds of radiolarians, and the colors are very strong and with different hue, like red, violet, and yellow. And this is some American typical material. This is from Flint Ridge, Ohio. Is a very old quarry used from Indian people, and is now in a national park, and is yet used for the production of knapped arrow. Another place very similar is the Alibat Flint Quarry in Texas, where also there is a massive bed of chert that was used from old Indian for production of arrow, and this bed is inside a dolomite sequence. So we can resume that the transformation of opal can produce jasper. So the opal A, that is the opal amorphous from microfossil, pass to jasper or flint with release of water. We know that opal contains water, and for this reason is very fragile, but jasper that lose water is very tough material. The obvious intermediate material is opal CT, that is a kind of opal more crystalline, where CT is for cristobalite tridymite, that are two phases of high temperature of quartz that have nothing to do with opal in this case, but when you make analysis there is some peak that are very similar to cristobalite and tridymite. So the term opal CT refers just to a kind of opal little bit more crystalline than the amorphous opal that is of organogenous origin. So this process is caused by diagenesis. So we have a loose opal A fragment that produce the massive jasper, red jasper, and the organic matter in this process is released and can migrate and go to form oil deposit. So we can understand this process where pressure and water circulation are responsible for this transformation. If we use an analogy, the olive oil pressing process, we take olives that are loose and we press in the mill, and we produce residual matter made of seed, and we have also the oil. So like the petroleum oil, we have the olive oil. So this is more or less the process involved, and the diagenesis is the term used for indicate the sum of all the process from deposition to the final formation of the rock. And usually diagenesis is pressure and water circulation. When water circulation can be hot water, hydrothermal water that come from deep, and meteoric water when the rock is just under air, above water in the chain, and this is rainwater that can circulate in the deposit and give more changement.